Welcome to Astronomy Chapter 19. Well, we've made it. The last chapter in this course. We're finally there, and the great news is this is another very short, very quick chapter we're going to be looking at. In fact, there's only half a dozen pages or so that we're going to be looking at in this chapter. It's going to go very quick, but this is one of the most thought-provoking, I think, perhaps the most thought-provoking of all of the stuff we have looked at in this course. Even as exciting as the well-known parts of our solar system are, or the constellations in the night sky, or the idea of learning about galaxies and dark matter and dark energy, the thing that I think drives more people and certainly drives me is the idea about life itself. The universe is a fascinating thing with all this matter and all this energy and all these things. But really, when you think about the grand scheme of human life and really any biological system, any biological thing, it is incredibly amazing that we find the biology that we find here on the Earth. And for as long as man has been around and realized that there are stars, and we have realized that there are other objects out there. As soon as we realized, Mars was a planet and Jupiter and Saturn were other planets, the question has become, well, if those are planets like our own, would we find life there as well? That is one of the most fundamental questions of all humanity is, are we alone? And perhaps the other most fundamental question that they address in this topic on astrobiology is, if are we alone is the first question, another very pertinent question should be, well, how then did life get here in the first place? If we have looked around, and at this point, we've looked pretty stinking hard, and we have not found life on our next door neighbor Mars, and we have looked at other objects and continue to look very hard. Europa is a possibility, Ganymede, Titan, other places for life existing. But yet we're the only place that we've seen any life. No fossils, no evidence, nothing anywhere else of life. That begs the question, so where did we come from? And of course, there are a variety of options for how to answer that question. And a lot of them go to religious answers, if you go to that way. And a lot of them go to some scientific explanations of this is how it could have worked. The reality is, we weren't here. I wasn't here, so we don't know how it all began at that initial moment. But what we do know is that we can study what's going on now and try to figure out, is there any other life out there? And that is a fascinatingly great idea to think about, is how much other life could be out there. And one of the first places that we look, they talk about here on 568, one of the first places we have looked is we have studied intensely the idea of looking for life on Mars. And we addressed that way back in the chapter on the other terrestrial worlds. And we do not see any information that leads us to think there's life there, or perhaps there was in the past, but certainly isn't there now. We there's all sorts of, this brings up such great discussion about the potential for life in other places. But if there were to be life in other places, what would that look like? That's one of the most fundamental questions about this is, so what would life look elsewhere? And the answer is we have no idea, because life here on Earth is dependent on a variety of very specific characteristics of our planet. A proper temperature, the existence of liquid water, the existence of carbon, and the use of carbon as it bonds to many other things. The question arises, if that is life as we understand it, what if there was life based off of nitrogen, or life based off of silicone, or life based off of any other compound other than carbon? What if there's life that existed in extremely cold environments? The answer is we don't know any of those things. And what we have found, though, is that we do not see life anywhere else that we have looked. And we have been looking pretty hard. Now, one of the things that we have done to try to look for this that I want to talk about is on page 572. One of the things that we do that we have been looking for is something called a habitable zone. And this is often affectionately known as the Goldilocks Zone. Because if you think about the story of Goldilocks and the Three Bears, there was the bowl of porridge that was too hot, there was a bowl of porridge that was too cold, and there was the bowl that was just right in the middle. Turns out our planet exists in a habitable zone, an area that is just the right temperature for life as we understand it. And so one of the things that we have done, if we are trying to find life similar to what we have on Earth, one of the things that we've been doing is we now have looked pretty hard for life in our solar system, and we will continue to do so. But now we have begun to search for Earth, another Earth, in a habitable zone around another star. So what we do is we are looking for all these exoplanets, which we talked about way back in like chapter 5. And so if we know there's a certain distance you need to be away from a star, then that gives us a clue of where to look to see if we could find a potential second Earth, if you will. And so we look for that, and we look in great painstaking detail. And in the meantime, we try to do things to approximate the likelihood of being able to find some of them. And the most famous approximation for this is what's known as the Drake equation. And the Drake equation answers one question. It says, how many civilizations are likely to exist in the Milky Way? Now, the reason why they wrap this up to only the Milky Way is because the distance between other galaxies is millions of light years. And the ability to ever travel from one galaxy to another galaxy seems absolutely preposterous. But being able to perhaps get around inside our own galaxy seems at least feasible, if with what we know. But being able to move to another galaxy simply to find life on other galaxies is almost irrelevant, because we would have absolutely no way to interact with them. But nonetheless, the Drake equation takes a variety of objects, and you should read through these. At the things of, what are the odds, the end that it solves for here is the number of estimated civilizations. And I have seen so many different versions of this that have been solved. The rate at which sun-like stars form, the fraction that have planets, the fraction that have planets suitable for life, the fraction that have where life arises, the fraction where it's intelligent life, the fraction where they create messages, and the fraction that technology exists within that civilization in our time frame. When you think about all of the things that are necessary for that, I have seen anywhere from saying that how many civilizations are there in the solar system, or excuse me, in the Milky Way, and 1/10 of one. And I have also seen they show you here another version of this saying a number could be as high as 10. So they talk about all sorts of variations of this Drake equation, but nonetheless it's very exciting. All right, the last thing I want to share in this chapter, and I'll quit, is it is the idea that we have been attempting to communicate and send information out there, putting our calling card out into space, saying who we are, where we are, and what's going on. And probably the most well-known example of this is the Voyager missions that left the Earth in the 1970s, Voyager 1 and Voyager 2, carrying this device called the Golden Record. The Golden Record has a variety of information about where the Earth is, about what is on the Earth, how the biological systems on the Earth made, and information about who we are and where we are. And it is written, of course, in sort of a cryptic system, trying to explain who we are and what we are. Nonetheless, it is a fascinating thought experiment that we are trying to communicate with anything that may be out there in space. So we have sent information out in an attempt that perhaps if it were to ever be picked up by another civilization, they could take that information and come and find us and perhaps be able to communicate. That in and of itself is probably, it's its own class right there. I mean, there's all sorts of questions. Is that even a good idea? Should we even be trying to communicate? Should we just be quiet and lay low? What if there are other civilizations out there? There's all sorts of fun experiments to think about with that. But the moral of the story is, everything that we have found so far leads us to believe that so far we are unique. We haven't found any other, there's never been another fossil found on another object. We've never found any sort of detection of life. We've never found any sort of, communication radiated out, and we put a lot of effort into trying to do that. So, the chapter on astrobiology is a fun thought experiment. There's only a couple things that you're going to be asked to do for the homework on this chapter, but I encourage you to make sure you're keeping up with the reading, and you should be able to handle this. And that is going to conclude the last of our chapters that we're going to be doing for this. You should be ready for your final exam and to wrap up your semester in astronomy. It's been a pleasure to have you with me, and we'll see you later. Good luck.